So yeah, now let's move ahead and see an example for the data agent. Um, I have here a query which is requesting top 5 customers by average order value. Notice that I am not specifying any specific column names or any specific table names. The model internally has access to a function which it can use to get the schema details and also to look up the memory in order to find the schema details. So we will see an implementation of how the model does here. Let's run this. Yeah, so as you can see, the model has started printing, doing its thing. I have asked it to, okay, there's an error, I think. Let's see what output is. Yeah, so yeah, yeah, so it looks like there were some errors, and PsycopG is the implementation for Postgres SQL. So it looks like there was some connection errors in using the memory tool. But this is a good example of how things can go pretty both ways in production. So these models are pretty impressive. You can see here that almost all the time the transfer and the transfer to respective agents always works well. I have instructed the data agent to look up the memory in order to get the schema before it uses the get schema summary table, get schema summary function. But I think in trying to search for schema information, the table has had some issues, I believe. So yeah, so the table internally the agent internally goes and accesses the get schema summary function. It gets the schema from the Snowflake instance. It generates the SQL query and then calls the run select function in order to get the details. And yes, so yeah, we see that yeah, one interesting thing which I have seen is the model uh, surprisingly does very well when in cases of ambiguous, like table names. So the model is able to figure out that by saying order value, we were referencing to the total price column here. And I have not defined any kind of uh, documentation or table um, data dictionary. Yeah, I have not defined any data dictionary to make sense of what table means or what individual rows mean in any of the tables. And I think that is a good candidate to consider uh, when we are talking about the latency of reducing the latency of the model, because that can, I think, significantly reduce the reasoning time. So yeah, we see that the model generates the query, it selects the the name of the customer, creates an order, like creates the average. It even joins using the customer key. And yeah, notice we have not specified anything anywhere. And yeah, it runs into run select issue because the customer's table doesn't exist. The table is customer. So the model internally even fixes that again, uh, runs the newly generated SQL, and here we see the average order value being given to us. And yeah, ultimately hand off to the supervisor. The model has even listed everything in descending order, so I think that's pretty nice. It's pretty neat. And the supervisor here is creating a new entry um, in the table. It is storing the schema information. It is saying, hey, these are the allowed tables, so we are able to use the customer, order, line item, nation, parts, blah blah blah. So these are the tables in our Snowflake schema. um, Here it is running into some issues trying to manage memory. I am pretty sure this can be due to rate limiting or something like that. This connection has been closed, huh? Okay. But yeah, here it is again trying to yeah, so we see that there are some issues with the memory tool, but we can fix that ahead. And ultimately the supervisor gives us the output. So yes, next up I will dive into each individual files and see what more we can do.